Is it
Hi
me?
everyone. No, it's me. Hi everyone, and welcome to the second day of Porto Cub. Um, I want to start by remembering you that you can ask questions for Josh on the stream tab on Umbrella. Josh, very welcome. I know it's 1 a.m. there. You are in the Pacific time, right?
Yes, sir.
And we will be talking about cloud native Java with Spring, probably.
Oh, something like that. Yep. Kubernetes native Java.
Okay. So are you ready to start, Josh?
Sure. Absolutely. Always.
Well, once again, thank you very much to be with us. And I know it's a bit difficult because for you it's a bit late. Thank you very much. And the stage is yours.
I appreciate it. Thank you so much, everybody, for being here. I know that there's a lot of places that you could be right now, but you chose to hang out with us today. That makes me so very happy. I appreciate that opportunity. My name is Josh Long. I am a Spring developer advocate on the Spring team. I'm a Java champion, a Kotlin Google developer expert. And most importantly, I'm at your service. So if you want to send me questions via Twitter or LinkedIn or email or whatever, don't hesitate to reach out. I also produce a lot of content, just trying to help people find their way to success in terms of the JVM ecosystem. So you might check out my podcast every week, a new episode on Fridays, your time. So today there's a new episode already. YouTube, I do a weekly series every Wednesday. I stream on Twitch. And of course, I've got a blog on joshlang.com. And the code for everything that we're going to look at today is here at github.com/Kubernetes native Java. Now, my friends, before we get too far down the road, we don't have all that much time. I'm told we have about 15 minutes. So let's quickly set the table. Let's motivate why we care about any of this stuff. So today, my friends, the goal is to discuss some of the things that we can do to make our trip to production more efficient, more safe, more predictable, more fun. Production these days for most people, as often as not, is Kubernetes. And so we want to make sure that we can build software that does the right thing in Kubernetes. Now, the question, of course, is why is it Kubernetes? I mean, why do we care, right? Why is this a big thing? And ultimately, Kubernetes is cloud infrastructure. And the reason we care about cloud infrastructure is not because it's something that's particularly novel. I mean, it's obviously great, right? But it's not like we didn't have a way to deploy software before, right? We've always had a way to deploy software. It just wasn't automated self-service. So what's interesting about this is that it's automated, it's fast. The cycle time from having an idea to seeing it deployed into production is greatly reduced, right? So this is the novel bit here, is that we have speed. Speed is what we're going for here. Speed is the name of the game, because the faster we can iterate, the faster we can take an idea and see it delivered into production, the more quickly we can validate that what we have done in production has worked, and then we can iterate upon that. We can expand upon it, we can change it, etc. We can respond to change, okay? This is super important. Speed and agility are what set our organization apart from other organizations. This is not a technical goal, right? The goal here is to go quickly so that we can learn, so that we can improve our organization. And if you always remember that, always keep that in your head, then a lot of technical discussions become very easy. Why do I care about cloud computing? Because it allows me to go faster. Why do I care about test-driven development? Because it gives me fast feedback as I'm making changes to my code. Why do I care about continuous integration and continuous delivery? Because they give me fast feedback. Why do I care about microservices? Because they give me fast feedback. So look at my organization, look at my large teams full of lots of people working on large code bases. These teams will have more difficulty changing code and delivering that code into production because there's more to stabilize, to integrate, and then to deploy. This costs more effort, more resources, more energy. Instead, what we want is to have smaller teams working on smaller code bases. And this is not, this is not a new idea, of course. Mel Conway in the 1970s, he said that software is a mirror image of the communication patterns of the organization. I don't think Mel Conway coughed right there. Mel Conway said that software is a mirror image of the communication patterns of the organization that builds it. So put another way, if your organization is dysfunctional, your software will be dysfunctional and reflect that organizational dysfunction. If you want to fix the software, you fix the organization. And so you've probably heard about small teams, right? Amazon talked about 2 pizza box teams. These are teams that are small enough that you can feed everybody on the team, all 5 or 6 or 7 people, with just 2 boxes of pizza. This is roughly 5, 6, 7 people, not a lot of people. And the reason is because you can keep all those people and all of their state, all of their context in your head, right? It's easy to remember what everybody's doing. You can go through the group and quickly make changes and have discussions and deliver value quickly without having lots of meetings to, specify what you already said to other people. This is valuable because it reduces cycle time, okay? So we want small teams. The problem, of course, is that sometimes our code bases are bigger than our teams. So what do? We break apart our code bases. And when we do that, what do we get? Well, we can't just cut code bases into small chunks, without concern for the boundaries of that break. So we have to look for logical places to make those cuts. And that logical place, it's kind of an art to find this. Obviously, we can look to Eric Evans. Eric Evans has a great book called Domain-Driven Design, in which he talks about something called a bounded context. A bounded context is a part of the domain model that stands by itself. If you can identify a bounded context, then you have a natural place along which to make this cut. So you have small code bases with small teams, and you want to be able to deploy independent of other teams. Well, this means that you cannot do a DLL. It cannot be a .jar that's linked into a .ear. It has to be standalone components, right? Standalone services. And this is where we get microservices. Microservices are a way for us to improve
Josh,
our organization. Yes.
You're not changing the slides, my friends.
There are no slides. There are no slides.
You have no slides. I'm sorry. I thought you were
slides.
flipping on the slides. Sorry to interrupt you. Carry on. Thank you.
It's okay.
Thank you.
Microservices are a way to improve organizational structure. They're not about technology. They're not about REST or gRPC or Kubernetes or anything, okay? So when we talk about cloud native Java, what we're talking about is software that's written in such a way that we can improve our organization. And if you understand that that goal is what we care about the most, then everything else becomes easier. So my friends, today in our brief time together, we're going to look at some patterns that are supported in the Spring ecosystem to make building software intended for production and intended for speed of iteration easier. And of course, to do that, my friends, we're going to go to start.spring.io. This is my second favorite place on the internet. My first favorite place on the internet, obviously, is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not already been, then you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application that uses the reactive web support. We'll use H2, which is an in-memory SQL data store. We're going to use the Spring Boot Actuator. We're going to use reactive web H2. R2DBC is the reactive relational database connectivity abstraction. And I think that's pretty good. We have some choices here. We have to specify the name of the module. I'm going to use customers. We're going to use literally, this was just released like in the last hour, 2.60. So, who knows? Maybe it'll be great. I don't know. We're going to use we have choices here. What kind of version or what kind of packaging do we want to use? Jar or war? I think the obvious answer is pretty clear. Make jar, not war. So we'll use that. And then the choice of what version of Java you would like to use. If you want to target GraalVM native images, then for the moment, since GraalVM just updated their compatibility for Java 17 in the last couple of weeks, we recommend Java 11, right? Because then you could use Spring Native. If you just want to use, the regular JRE, then Java 17 is the only choice you really have. Java 8 is slow and old and less performant and less rich, less syntax rich, less observable, less performant, less robust, less secure. It is technically inferior in every way compared to Java 17. It is also morally inferior. in every way compared to Java 17. You will not like the look of sadness and disgust in your children's eyes when they see that you are using Java 8 in production. Don't do it. Be the change you want to see in the world. Do the right thing, use Java 17. So I'll go ahead and generate this and open this up in my IDE while I also turn down the heat here. Okay. Okay. So we have our basic dependencies. I don't need the JDBC dependency for H2. It adds nothing, so I'll just remove that. I'm going to go ahead and re-import like so. We're going to create a new application here. And it's just a public static void main application. This application uses reactive APIs. The whole point of reactive programming is to support 3 key concerns. And these are ideal, these are natural things to care about in a cloud native environment where things may fail, where things come and go, things are volatile, where services are distributed, and where the network is not infinitely fast and services are not always available. Reactive programming gives us 3 big benefits. The first is resource efficiency. It is the ability to write code in such a way that we give the scheduler ideas about when we are not using the thread. And the scheduler can move our work off of the thread and onto a background off into the background where we can then not use the threads in the system. This allows other things in the system to use those threads. Reactive programming, therefore, gives us much better scalability. It gives us the ability to handle many more requests at the same time. This is naturally a very good thing in a cloud native environment. Microservices also give us a single abstraction to talk about data. This is very important because imagine you want to consume data from a REST endpoint with 5 records, 5 objects that come back. Okay, no big deal. You can maybe use a collection. What if you want to use messages from Apache Kafka or RabbitMQ? Well, this is different, right? In this case, the data will come forever. It's always going to come. There might be billions of messages. There might be 2 messages, but the point is they might be spaced apart. You might have 1 message now. You might have another message in a week. You just don't know. It's asynchronous, right? So a collection doesn't make sense here. You have to have another abstraction. And this is the problem. So much of the boring and dangerous code that we write when we build microservices is about taking data from one data source and adapting it to another. So imagine somebody asks you to get the data from Apache Kafka and send it out over WebSockets. You have to write glue code. You have to write code that adapts one into the other. This is no fun, right? This is dangerous. So with reactive streams, you have one type. This means that it's much easier to compose your different streams of data. It doesn't matter if it's infinite stream of data coming from Apache Kafka or RabbitMQ or whatever. It doesn't matter if it's 2 records coming from a JDBC SQL query or a MongoDB database or whatever. It's still just a reactive stream. It's reactive streams all the way down. This means that you can throw away in your brain all these APIs that don't line up and don't match and don't work. You can throw all those away and you start to think about the world in reactive streams. Life becomes much easier. It's actually cleaner code and it's easier to reason about. So it's better code while also being the more performant code, which is nice. You don't very often in life get a situation where the most elegant code is also the most performant, most scalable code. The third benefit that you get from reactive streams and reactive programming is that you have a single abstraction and therefore you have a single place where you can address a lot of the concerns that you encounter when you build distributed systems. What happens when one side goes faster than the other? Well, you need back pressure, you need flow control. What happens if something is failing? Well, you might want a timeout or a retry. All of this can be handled by one library, the reactive streams library, so the reactive streams implementations. So we will be using reactive programming. I want you to understand why, even though we're not going to spend a lot of time introducing it. I think it'll be pretty natural. So the first thing that we want is to build a type of record to match the data that we're going to describe in our database. So I'm going to create a record. Okay, this is a Java 17 feature. And Then I want to persist this record into the database. So I'll create a customer repository, like so. Customer integer. Okay, there we are. And we're going to create some tables and some SQL data. Okay, so I'll go over here and I'll create a file called schema.sql. And here I'm just going to define a file called schema. So ID serial primary key, name varchar. This is in my way. Name varchar 255 not null. Okay, so I'm just defining a very simple schema. And then I want to have a new file called data.sql. Okay, and in this, I'm going to write some people into the database. And these are going to be people in particular that are, people on the Spring team, just a few of them. So Madura is on the Spring team. Olga, she's on the Spring team. Yushin, she's on the Spring team. Violetta, she's on the Spring team. Who else? I'm on the Spring team. I don't know how, but I am. I'm very lucky that way. Dr. Sire, he's on the Spring team. Stefan, he's on the Spring team. And Spencer, he's on the Spring team. So that's a few of us, okay? So now we have some records in the database. We have our basic reactive CRUD repository. And now I want to build an HTTP API to talk to that. So I'll build a controller here. And this will have response bodies. So I'll specify that. And I'm going to create an endpoint here. Whoops. Publisher of customer. Now, of course, in order to do my work, I need to inject this repository that we just created. So I'll create a constructor here for that. Voila. Return this dot repository find all. Okay, very good. Let's go ahead and start this up and see what we get. Oh, what did I do? Have I insert into customer value? Okay, I think it's values. Awkward. Oh. Awkward. Okay, so let's try this again. Okay, well, what port? We're on port 8080, okay? Localhost 8080 customers, et voila, there we go, good. Are we done? Can we go to production yet? Of course not, right? There are some things that we need to care about still. First and foremost, observability. And one way we can support observability is to use the Spring Boot Actuator. The idea behind observability is that we want to know what our application is doing in production. So even though I have a little reactive HTTP endpoint that talks to a SQL database, I still don't know what it's doing. And so to support that, I'm going to enable some of these modules, some of these endpoints for our application. Now, of course, you will. This is a demo, right? I'm showing all the details instead of locking it behind security or something like that. I'm just going to show everything all the time. This is not a very good demo for live code, for real production code, but for our demo, it does help kind of understand what's happening. We also want the Kubernetes probes. We'll enable those. So let's go ahead and restart. And this would give us some endpoints under Actuator, okay? So let's see. Actuator, here we go. We have several different endpoints here that give us information about the state of the service. So the Actuator, the beans endpoint, the caches, the health endpoint, info endpoint, condition, config props, env, etc. All of these are designed to support what the application is doing. So the beans endpoint shows us all the different Java objects and their relationships, their scopes, their classes, their dependencies, etc. The caches endpoint shows us all the different cache implementations in the application and their relationships to each other. The health endpoint shows us the different subsystems in the application that, if they were to fail, would mean that the service is no longer fit for production, okay? So, for example, my file system and my database connection, this is all reflected here. We've also got Kubernetes probes, and we'll talk about this in a second. But these probes are good for the Kubernetes readiness probe, which is a sensor. It's a thing that Kubernetes checks to see if the service is ready to be in production. And then there's the liveness probe, which is the one that Kubernetes checks to see if the service is still fit for production, okay? We've also got the health endpoint we just talked about. We've got the info endpoint. The info endpoint gives us information about the application. So imagine this. Imagine you have got an application and you've written some changes, you've coded some changes to the code, hack, git commit, git push, it goes to a CI environment. In the CI environment, GitHub Actions or something like this, you build the code and then you put it in a jar, and you put that jar inside of a Docker image. And you might use something like build packs, which is built into Spring Boot. Like if you want to use build packs, you can just say cd customers Maven Spring Boot build image, and this will build a Docker image for you. And then you can Docker tag and Docker push that, right? So you can do that, or you might use, and behind the scenes that uses build packs, right? This is a cloud native computing specification. It's just a very simple way to take a jar or .NET exe or a Python application or a Ruby on Rails application or whatever and turn it into a container. So now you've got a container and you want to deploy it, right? So that gets deployed to Google Container Registry or VMware Harbor or Docker Hub or something like this. Now you want to deploy it. You have a Flux continuous delivery pipeline on the other side that sees the new Docker image and applies your Kubernetes resources into production. So all of this happens automatically. You make changes, git commit, Docker container, container registry, and then your continuous delivery pipeline, and then suddenly something is deployed in production. Okay, so you've got all this pipeline happening. What happens if there's a bug? Well, how do you know what version of the software is there? The info endpoint can be a good way to see which one you're using. You might also check the Docker tag for your different container, but if you want to just look at an endpoint and see what it is, this is a good place to put that. So you can put that in here. You can do a couple things. You can say, okay, well, hello, hello world, right? You can do this kind of thing. Another thing you might do is use the Spring Boot pre-configured Maven plugin for Git commit ID, okay? So I'm gonna go ahead and copy and paste this into my build down here, plugin, over here, plugin. All right, so I've got this Git commit ID, and the way that this works is you have to have a Git repository. So I say git init, git add, okay, git status, git commit, YOLO. Okay, now Maven, skip tests, clean package. And what that's going to do is it's going to build an application with the Git properties in there, right? And so the Git properties are here. And this shows me things like my Git commit ID, the build time, the commit hash, etc. And this is all very useful if I want to understand what version of the software is running in production. Well, the Spring Boot Actuator already includes all that here, right? So I've got this configuration. The application tells me what version of the code is running there. That's very convenient, very good for observability. We've also got the conditions endpoint, which shows me all the different conditions that Spring Boot evaluates to arrive at the final congealed form of the application. We've got the config props endpoint, which shows me the different configuration properties and how they relate to each other. So for example, you saw me earlier specify management.endpoints.web.exposure.include is equal to asterisk, right? I specified that here, right? This one. So these are all the different properties that you can use for Spring Boot. We've got the env, which shows you the different environment variables and system properties and all this kind of stuff that you need to understand what the application is doing. Because remember, system properties and environment variables can act on your application for you. We've got the loggers endpoint, and you've got the loggers name endpoint. So this gives you the log levels for all the different loggers you can post to this to update the log levels. You've also got the heap dump and thread dump, which give you things that you can plug into your profile and you can inspect. You've got the metrics endpoint, which gives you statistics about the application. For example, how long it's been around, the disk free, how many HTTP requests, etc. And this is all powered behind the scenes using something called Micrometer. Micrometer is a vendor-neutral application metrics facade. It supports time series databases like AppOptics, Azure Monitor, Netflix Atlas, Prometheus in Kubernetes, for example, VMware Wavefront, Google Cloud Stackdriver, StatsD. I mean, all these things, right? All these things you want to look at the statistics, the health of your application. It's powered, it's supported by this library, and that's what powers this endpoint here, okay? What else do we have? Well, we've got the scheduled task and the mappings endpoint. The mappings endpoint shows me all the different subsystems, all the different URLs, and their MIME types, they're accepted and rejected. The handler methods, the predicates, all that kind of stuff is specified here. So we have a lot of different endpoints. I want to talk about that health endpoint. This health endpoint, like I say, it shows me information about the health of the application. I can go to my application itself here, customers, and I'm going to build a simple customers endpoint. So customers, health, or let's just call it health controller, right? And this will be a @controller response body. And let's suppose I want to inject the Spring Framework application context, right? So I'll say inject the context, please. Give me that, and I want to shut down the application. So I'm going to say mono of void down return, and I'll just say return mono.empty, sure, availability change event dot publish this dot context. And what I want to do is I'm going to create an endpoint that will make those probes go down, right? And so the different probes are the liveness and readiness probes. So let's say liveness is broken, okay? So something in my code has gone wrong somewhere, something is not working. I publish this event. This is an event that gets published on the application context. Spring has an event bus for intra-communication, for intra-component communication. So I'm just using that to publish this event, okay? So let's go ahead and restart. And we can say curl HTTP localhost 8080 /actuator /health /liveness. Okay, it's up, good. Now, what about this? We say curl -x post HTTP localhost 8080 /down, okay? And now you can see that the status is down. So I published that event, triggered an application context event, and now the application is down. Well, okay, if I call that endpoint again, -v, you can see that the service is 503. So this load balancer will easily be able to understand that that's down, even if it doesn't parse the JSON. Now, this probe, what does Kubernetes do when it sees this? Well, of course, it's going to try and decommission your pod, your deployment, and then replace it with a new one. So this is very important. We need to understand what's going to happen. It's going to try and shut down this application. The question, of course, is what happens if your application is running? Well, if it's running, then you want to make sure that it gives your application some time to gracefully finish its work. And so this is what this parameter is. By default, what happens is you get sig term. Sig term means please shut down. And then very quickly you get sig kill, which is you're over, it's done. Basta, no more, right? Server.shutdown is not what you want here. You want server.shutdown equals graceful, right? Graceful is good because Spring will stop accepting new requests and it'll allow you to finish any work you've got, but you only have a certain amount of time. So you can say, give me 30 seconds or whatever. That's the default. You have to specify this in your deployment as well, your Kubernetes pod or deployment. You have to specify the timeout. But this is good because now you can make sure you have time to finish any in-flight transactions. Okay, so we have now an application. We know that we're going to go to production in Kubernetes. There's going to be some configuration that is specific to Kubernetes. So I want to make sure that that configuration is separate. The Kubernetes probes, this graceful shutdown, that's only applicable there. So this is all Kubernetes stuff. This is everything. This is Kubernetes. This is generic default stuff. So what I want to do is have a separate configuration set. And I can use the syntax to divide this property file. I can say activate on cloud platform equals Kubernetes. So instead of just using a Spring profile, I can actually have configuration sets that are specific to a runtime environment. I can also have beans, and endpoints that are specific to a runtime environment. So I can say, this is only active when this is inside of Kubernetes, or I can create a bean that just logs something. So I can go here, bean application runner, system out, hello, Kates. Okay, voila. So this, in order to trick our application, because remember, right now on my local machine, I need to tell it that we are inside of Kubernetes, and I can do this by overriding this property and then specifying that in the run configuration for the application. So I'll go here to the environment and I'll say program arguments equals -- spring.main.cloud-platform equals Kubernetes, and I'll restart. And now we should see configuration that only exists when we're in that environment, right? So there's our Hello Kate's application, and you go here, and you can see if I remove this, hit OK, restart again. Goody. Okay, so there's our application. You don't see Hello Kate's anywhere, right? Very good. So there's our endpoint. We now have the application. We have our ability to separate out our configuration based on the environment we're in. I think we're ready to go to production. And again, there's some concerns you need to care about. You need to create a container. Now, again, don't freak out. You can use build packs, right? I showed you that before. Build packs are it's a separate command line utility if you want, and you can use it for other languages. But if you're using Spring Boot, you can just use the Maven or Gradle plugin. The question then is, what happens if you want to go to production using GraalVM? Well, you can do that as well, right? So GraalVM is a just-in-time compiler that has a separate component that supports ahead-of-time compilation. We have experimental support. The goal is that for this experimental support, I don't know if this will go GA by itself. It's a separate project called Spring Native. You can also use it right now. It works just fine. But the goal is for that to be baked into Spring Framework 6 due next year. It's coming out next year. And Spring Boot 3 will also support that. So it'll be a core part of Spring as of next year, as of the those releases of next year. In the meantime, you can try it out as a separate project. And it works. It's a nice thing. But unfortunately, it takes about 5 minutes. And the reason it takes 5 minutes for this kind of application is because GraalVM native image capability is an ahead of time compiler. It looks at your code at compile time and decides what in your code will be used at runtime. The problem is that this is not a NP complete kind of problem. You cannot understand at compile time everything that your application is going to do at runtime. And Java, even though it sometimes feels a bit like C or C++, is actually much more like JavaScript and Python and PHP and Ruby in that it is very dynamic. You can do a lot of things at runtime, a lot of things, really amazing things. You can actually create a string that has a class definition. You can take that class definition, compile it at runtime, put that new class that's been compiled into the class loader, use reflection to instantiate an instance of that class, or create a JDK proxy from that class. And then you can write the bytes for that class to disk using Java serialization and then send that over the network, all at runtime, all without ever having a concrete instance of your type in your code. It's all just Java lang object references and so on. So Java is a very dynamic thing, and you must tell GraalVM, hey, please don't throw away that code because I'm going to use it. So Spring Native provides all of that configuration. It provides all the hints so that your application, where it does use these kinds of things, still works. So that's a very interesting thing. I encourage you to check it out. But I'm using Java 17, so I won't be using that here. But you can see it's easy to get the configuration. You can just look at the configuration here, and you can see it brings in the Maven plugin and an AOT Maven plugin. It adds the milestones. It configures a native profile. So you can just say Maven -P, capital P, native, clean package, and then you go. Okay, so I've got a simple microservice. I've got my application. I want to go to production. I'm going to use, I've got my HTTP customers endpoint. I want to now have another service to manage profile data. So I'm going to go back to start.spring.io. Whoa, no profiles. I'm going to create an RSocket application. RSocket is a different binary. It's a different protocol than HTTP. It was created by engineers at Facebook and Netflix. It is a binary protocol that is meant to get around some of the limitations of HTTP 1, HTTP 2, and gRPC. This is a reactive first network protocol. So it's meant to scale. It supports many different message exchange patterns, not just request response. It also supports fire and forget. It supports bi-directional streaming. It's a very nice protocol. So I'm going to use that to create a profile endpoint, data about our applications, and we'll create a record here. And, it's just a very simple domain model here. For each customer ID, we'll have a profile ID. And then I'm going to create a profile controller, right? A profile RSocket controller. Now we have to, in order to use RSocket, we need to have an RSocket service running. So I'll say RSocket server port is equal to 8181. And we're going to just make this a regular Spring controller, just as before. And we're going to have a constructor that we use to initialize our database. I'm just going to create a little in-memory database of customer IDs to profile objects, okay? So DB new concurrent hash map. Now, of course, you can use any database you like. Obviously, I used R2DBC before. This is a reactive relational database connectivity abstraction. It supports protocols like database drivers like Oracle, SQL Server, H2, MariaDB, MySQL, SAP HANA, Google Cloud Spanner, etc. I mean, all the big ones are all there. And of course, you have the rest of the Spring Data portfolio to support other reactive data integration layers like MongoDB, Neo4j, Couchbase, Redis, etc. So there are lots of different reactive options. But for our purposes, for this little demo, I'm just going to write 8 hard-coded records. Okay. So customer ID plus customer ID is equal to 1. And I'll say this.db.put customer ID new profile. So the ID will be the ID of the customer of the profile, right? So there we go. ID, customer ID, and just ID plus equals 1. There we go. So this is my very simple loop. Now I want people to be able to get their data. So I'll create an RSocket endpoint. I'll say when people want the profiles data, we'll allow them to search it by going to this endpoint. Okay. Profile for destination variable, integer customer ID. Okay, return this.db. Actually, we don't even need the mono. It's not strictly speaking required. So there we are. Okay, so there's our very simple RSocket service. Let's go ahead and start this up. Alrighty, and now I've got a RSocket service. I've got an HTTP service. Now I want to create a edge service. So I'll return to the initializer, and the edge services, the whole point of the edge services is to support adapting requests that come in from the outside to our microservices. There are 2 very common reasons why you might want to do this. Imagine you have different clients that speak different protocols and maybe have different kinds of security. Rather than changing every single microservice to accommodate each of these new clients, you've got Android, iOS, iPhone, PlayStation, Xbox, Roku, watch, tablet, everything like that. Rather than changing every microservice to accommodate each new client, you can centralize these client-specific concerns in the edge service and allow it to adapt the microservices to the client. That way, each client has its own edge service. It's a back end for a front end, right? This is a very common pattern. Another reason you might want to do this is because there are certain cross-cutting concerns that you want to do them. You want to have autonomy. This should not be business logic, really. They should be low-hanging fruit, things that you can do in a single place without being coupled to other services, things like compression and routing and security. This is stuff that you could reintroduce into every single microservice, but it would be redundant and it doesn't need to be. So we're going to use Spring Cloud Gateway to create an API gateway. That's the first kind of edge service. So this will be a port. This will run on port 9999, and we're going to create a Spring Bean here at bean route locator. Locator builder. Okay, and Spring Cloud Gateway is an API gateway. So you define routes, and each route has 3 main components, right? The route has the predicate that matches a incoming request. So here I'm saying that the incoming request coming to port 9999 must have a path called proxy, and it must have the vhost header called .host. And then if it matches that, I will send this request onward to customers, right? Okay, well, what if I want to change the request? Well, I can use a filter to change the body of the request or to change the headers. So for example, the incoming request will be proxy, the path will be proxy. And so if I forward it without changing it, it'll end up like this, which doesn't work, it doesn't exist. So I need to change it here using a filter, right? I can do all sorts of very interesting things here. I can actually say add a response header, HTTP headers, dot access control allow origin. I can do a retry. I can do all sorts of things here to make my service proxy a little bit more robust. Let's start that up as well. Okay, and I go here, I say curl HTTP localhost 9999/proxy. Now, this won't work. Watch, if I do V, you'll see it says 404, right? I need a host header. So I say host is hi.spring.io. And there we go. There's my data. Okay. Oh, Netty is complaining about a native library that for some reason it's not finding. Okay, so this is this is the data from the downstream service. Great. That's a Spring Cloud Gateway use case. I like that. But sometimes I want to do more than just proxy the data. Suppose I want to create an endpoint that gives me a new view of the data, right? And imagine you're building a client, an Android client, and it's going to be distributed to people where the signal may not be so great, right? Very common scenario. Imagine you're on your Android device, you've got 3G service, and you're going through a tunnel, right? Like the worst possible scenario. And it would not be very efficient for the battery or for efficiency in terms of latency. It would not be very efficient if that Android client has to call RSocket and 3 other HTTP services to get its data back, right? Instead, we want to do the service orchestration and composition on the server side. So I'll create a CRM client, and this CRM client will use the reactive non-blocking HTTP client and the RSocket client. Let's inject these in the constructor like so. But we also need to build those instances. We need to create factory bean. We need to factory those objects, okay? So RSocket requester builder.tcp localhost 8181. There's this. We also want to create the web client .builder. Okay, return builder.build. Very good. Okay, so we have web client. We have RSocket requester. You notice that the pattern is fairly familiar, very approachable. But the thing about RSocket is that it's a stateful protocol. So when it starts up, it maintains one socket to the server and it stays connected. There's no reconnecting. There's no new handshakes. You start up once and then that same socket is multiplexed for all the concurrent requests. Okay, so now let's say I want to get my data. Okay, so I have some DTOs here. We have a record for the customer, integer ID, string name, a record for the profile, integer ID and integer customer ID. And I will call the customer service and get all the customers like this. I'll say return this.http.get URI localhost 8080/customers. And I'm going to get the data and turn it back into a customer.class. Good, not bad. What about the profile data? Okay, so I'll get profile for integer customer ID. Okay, and I'll say return this.rsocket.route profiles.cid customer ID, retrieve mono profile.class, etc. Good. So these are both reactive types. These are both like publishers. At the end of the day, they're reactive stream publisher types. Both of them, Flux and mono, are both publishers. This has 0 to n values. This has only at most 1 value. But there's endpoints. What if something goes wrong? Well, because they're both reactive stream types from Project Reactor, you can easily address those potential error cases using operators that are built in to these types, right? So I can do back off. I can say, I want it to back off 10 times. I want to do a timeout. I want to do an on error resume, right? On error resume. When something goes wrong, I can return an empty reactive stream. There you go. So these are the 3 reactive types, or 3 different operators, but they're not unique to HTTP or RSocket. They're reactor types, right? So this is obviously mono.mt, but still, I don't have to reinvent this stuff for each type. I just have reactive streams. It supports what I'm trying to do. Okay, so I've got my profile data, my customer data. Now I want to compose that together. I will create a new type called a customer profile. So customer profile And on the left, I'll have the customer. And on the right, I'll have the profile, right? So I want to get this data into one view of the data. And I will do this by saying, give me a publisher of customer profile, get customer profiles. And I'll say return this.get customers .flat map. And then for each customer, I want to store in memory both the customer itself. So here's the customer, as well as the profile for the customer. So customer.id. And then I want to turn that, which is now a tuple. It's just called it's called a tuple, into a new customer profile object. So tuple.get T1 is customer, tuple.get T2 is the profile. Okay, and that's behind the scenes doing reactive service orchestration and composition. It's scatter gather service orchestration and composition, and yet it's happening concurrently. I don't have to write that code using threads and runnables and phasers and countdown latches or anything like that. It's the best code while also being the most scalable code. Okay, so let's expose that here. Return this dot, and we have to inject our CRM client, CRM dot get customer profiles. Okay, good. Now this is going to work. This is fine. We'll show that in a second, but I want to also introduce a data integration layer. And the easiest way to do that these days is to use GraphQL. So I'm going to very quickly show you some, not yet GA, so I need the milestones, versions of GraphQL with a project called Spring GraphQL, okay?
Josh,
so, yes, 2 minutes.
Yes.
Yeah, don't worry. So now I'm going to add these dependencies here. I'll go down here to the build, paste that in, Maven, reload project, and I will now add to my build the Spring GraphQL dependency. Uh-oh, what's wrong with the build? Everything happy? Oh, repositories. One. Hello, okay. Maven, reload project, and then plugin repositories. Are you having the same problem? Okay, good. So now I'm going to add this GraphQL dependency very quickly here. Say GraphQL Spring Boot Starter. Voila, there's the dependency. And I want to very quickly create a GraphQL controller for my data. So I will create a schema, source main resources, directory called GraphQL, and a new file here called schema.graphqls. And in this, I'll create a type called a query, and I'll have a field called customers, which shows me all the customer data, and another type called customer for my customer records. And this will have the ID and the name. And then finally, the profile information, which will come from another microservice, right? So I need to make sure I keep that in mind as well. ID, and customer ID, okay? Now I need to implement this in my Java code. So let's go back here and create a GraphQL controller using Spring GraphQL, which uses the same engine as the GraphQL that Twitter uses, right? So CRM GraphQL controller. And we're going to create a schema mapping endpoint. Type name is equal to query. Field is equal, we don't need this field. So publisher of customers. And we're going to use a private final CRM client, CRM. Okay, now, sorry, my friends. Return this.crm dot get customers. Very good. What about this one? Schema mapping type customer profile. Okay, for the customer, the root profile, the root customer object there. Customer return this.crm dot profile. Get customer profile, and I'm going to pass in the profile. So profiles for customer.id. Okay, so I'm returning a reactive stream for this and a reactive stream for that, but they're both resolving data. Let's go ahead and restart this and see what we get. Localhost 9999 / oh, there it is. There's my original service orchestration. And then I want to get the GraphQL information as well. GraphQL. I can do a query. I can say, okay, refresh this, refresh, good. I can do a query. I get the customer data, ID, good. What about the profile data? Good. There we go. So I can do reactive service orchestration composition. Thank you so much for your time, Obrigado. I appreciate you all. I hope you got something out of this. I'm sorry that we have no time for questions. Please don't hesitate to find me on the Twitters. I'm at StarbucksMan, where my direct messages are wide open. It's been a lot of fun. I wish we could have done this in person. Thank you so much.
Next year, Josh, we can do it in person next year.
Experimente.
Yeah, I'm sure people, all the attendees who are thinking, oh, this guy is very slow, right? Super fast paced.
It is after one. It's almost 2, so I'm very tired. Imagine if I had coffee.
Yeah, I could imagine. Thank you very much, Josh. I hope to see you again next year.
Me too, my friend. Good night or good morning.
Thank you very much. Good morning for us. Bye. Thank you very much.